All right, Dr. Glen Zielinski, welcome to Life After Impact, the Concussion Recovery Podcast. You are a chiropractic physician and board-certified functional neurologist with an absolutely beautiful clinic in Lake Oswego, Oregon, and I've had the opportunity to shadow you in your clinic for a week, which was incredible for me to see how you run your practice, how you operate, and I learned so much. And I brought you onto the show today to talk about your integration of transcranial magnetic stimulation with all of your other tools, techniques, therapies, specifically for people with traumatic brain injuries. So welcome to the show, and thank you for being here.
Hey, happy to be here.
Yeah, so tell me a little bit about your clinic. I know that you do 5-day intensives primarily. Is that correct?
Yeah, generally. That's probably the
Yeah,
majority of our
so
business at this point.
Yeah, so you get to spend a whole week with people and really get to see them from beginning to end. And tell me a little bit about, you know, your integration of the technology, especially that TMS, and when did you bring that into your clinic, and what has that looked like, or how has that evolved over time?
All right. Well, so we have been using TMS in our practice since I think 2018 or early 2019. We've gone through a couple of different TMS systems. Currently, we're using a system by a company called MagVenture. And the beauty of that is that unlike most TMS, where the process just largely comes down to finding a motor threshold on somebody by, moving this coil around and figuring out where your thumb twitches and saying, okay, here's the primary motor cortex, the areas that we want to stimulate. Now we're just going to measure based on landmarks and hope for the best, hope that we're getting close. We now have a system that's neuro-navigated, which means we use this MRI database. We upload a brain MRI. It feeds it into this AI thing. It stretches it out and morphs the AI brain into a way that allows us to identify any area on the cortex that we want to stimulate and hit it within like half a millimeter, which is pretty fantastic. So that's given us some pretty dramatic increases in terms of what we can and can't treat with TMS. Traditional TMS is largely used to just stimulate the dorsolateral prefrontal cortex, which is a critically important area. I mean, it's a massively important node in the default mode network and in the salience network. And it's sort of like the apex of cognition within the frontal lobe. Just about everything runs into the DLPFC, and just about everything is stimulated one way or another by the DLPFC. And as a consequence, it's an area that is impacted almost inevitably in concussion. There's research that shows that by the time you've had two significant hits, you've got a problem with your DLPFC. People are looking at DLPFC problems as now a biomarker of post-concussion syndrome, as in if you don't show some dysfunction in that system, then you've got problems, something beyond just concussion. There's something else going on. Now, traditional TMS just stimulates that, and if you go to see your average TMS clinic, they're just going to do left DLPFC because that's the only protocol that they've been trained in. Your average psychiatric practice is just doing that and that alone, right? And that is very relevant for a lot of patients, but by no means all patients, right? There's tons of people that have problems on the right side, for example. And if you have a right DLPFC lesion, then that's not exactly helpful. You may even be making somebody worse by doing that kind of stimulus. So the key is with TMS, you need to understand, first of all, what it is that you're trying to accomplish. And it's not as simple as the sort of traditional psychiatric, do a PHQ-9 depression scale and see if your scores are low. And if they're low, then let's do TMS. What we do is based, first of all, on some pretty heavy neurodiagnostics. And the neurodiagnostics that we engage in are we address every conceivable system. We do something like 50 odd discrete tests that give us objective data on what's going on with somebody's brain before we even start any kind of therapy. And one of the things that we pay quite a bit of attention to is anti-saccadimetry. Now, saccadimetry is a system that I helped develop for this company called Interacoustics, which does video nystagmography testing. And video nystagmography is infrared cameras, you're tracking your pupils, you're seeing various different types of stimulation take place on a screen, and you're the system basically just records eye movements in response to the different types of stimulus. This is probably the best way to see really what's going on with somebody's brain after a concussion, because all of the systems that tend to be impacted by all the rotational shearing forces that happen when your head gets snapped around, we can see function in all of those systems by looking at eye movements, because eye movements all start in the same part of the brainstem, which is an area that that's sort of like the apex of all the rotation. I mean, if you just think of a concussion as like, if your brain's like a big cauliflower and the brain stem is the stalk of the cauliflower, all the maps that your brain uses to make sense out of where you are in the world, they all live in different parts of the cortex, but they integrate right in the middle of the pons in the midbrain, which is basically the stalk of the cauliflower. And getting concussed is like you grab the stalk of the cauliflower and just snap it really fast, and all these rotational shearing forces go right where you're holding, which means right where you put all those maps together. And that's also the areas that not only control all your autonomic nervous system, but also the areas that basically generate all of your eye movements. And different types of eye movements coming from different parts of the brain can show you a ton about what's happening in the different parts of the brain stem and cerebellum and parietal lobe and frontal lobe and basal ganglia and all the pathways in between that have a tendency to be affected by these things. And it's one thing to be able to see that somebody has a problem on an image, and it's another thing entirely to see under what sets of circumstances those pathways fatigue and fail, what kind of stimulus pushes them over the edge, what makes them melt down, and so on and so forth. And that can give you like a massive amount of information about what's happening with somebody's brain after a concussion. And it doesn't just show you what's wrong, it shows you, if you understand what you're looking at, it shows you what to do about it, how to get somebody better, right? Now, there is a specific eye movement called a saccade, which is a fast jump from target to target. And this is how you build your environmental map. Saccades come from your frontal lobe through your basal ganglia into your midbrain and down into the pons. So basically, that whole brainstem pathway is being driven by descending frontal lobe output. And again, frontal lobe is cognition, executive function, and so on and so forth, right? Everything that people like to think of as consciousness is mostly frontal lobe. And when you talk about people having cognitive problems, you're talking about some kind of a frontal lobe deficit in most cases. Now, so again, a saccade is moving from target to target, going towards something that's called a prosaccade. An anti-saccade is a whole other ball of wax. An anti-saccade is you have a target and your brain has a reflex that wants to make you move towards that target, but you have to be able to inhibit that reflex, and then you have to be able to move your eyes in the opposite direction. Now, that is a higher level executive function task that comes from specifically an area called the dorsolateral prefrontal cortex, the DLPFC. And generating anti-saccades with stimulus on the right is a function of the left DLPFC and vice versa. There is a ton of new emerging evidence around how anti-saccades get messed up when somebody has concussion. I mean, I presented on that at the Barony Society meeting in Madrid a couple of years ago at the biggest vestibular conference in the world. The whole idea of anti-saccades is they're not just about you being able to not look at a target. They're about response inhibition. All right. And response inhibition is essentially, if you're capable of listening to me, it's because you're inhibiting the sound of the birds chirping behind my head, right? Or the sensation of your butt on the chair that you're sitting on, and all this other sensory input that's just there at all times. And if you can't inhibit, then you sort of become a slave to the environment. And you get what we like to call squirrel brain, in the sense that you're in the middle of squirrel, and you can't inhibit environmental stimulation. Now, that's massively problematic when people get into complicated sensory environments. Because if you can't inhibit what's happening around you, if you can't inhibit all the visual stimulation, if you can't inhibit all the auditory stimulation, Costco is like our final exam for our patients, because that's the most overwhelming circumstance that we can put anybody in terms of visual and auditory and cognitive tasks and so on and so forth. If you can't inhibit that kind of stuff, you can't function in the world. And that's why people find inevitably that they get into complicated sensory environments and they have meltdowns. So an anti-saccade very specifically looks at your ability to inhibit the world. And if it doesn't work, then good luck, right? Okay, so anti-saccades come from the dorsolateral prefrontal cortex, and traditional TMS is basically geared towards stimulating the DLPFC directly. So if you're not familiar with TMS, it's this big MRI strength magnet with a very focal beam. You place it directly over your DLPFC with traditional TMS. It's the weirdest sensation in the world. it feels like somebody's snapping you in the forehead with an elastic band, but it sounds like somebody's drilling a mallet into your head with a big wooden stake. Like, it's
Oh,
just crazy.
fun.
But it's not. I mean, most people don't have any problem with it. I mean, there's the odd person that can't tolerate the stimulus, but I mean, we have more patients that fall asleep in the chair during TMS than we do people that can't handle it. But the point is that it directly stimulates that pathway. It directly stimulates the dorsolateral prefrontal cortex from through your skull, and it lights it up like a Christmas tree. So when TMS was first presented, when it first got its FDA approval, the thing about TMS was that if you looked at the response rate of SSRIs, the antidepressant medications that most people go on if they have chronic refractory depression, the response rate on an SSRI is something like 22% for the first med, and then it's something like 14% for the second med, and like 3 or 4% for the third med, with response being 50% improvement or better. And if you haven't responded by the third med, almost inevitably you're not responding. Okay. And what that means is that the majority of the depressed population don't respond to meds, right? They just don't have the benefit that everybody's supposed to get. So TMS was originally studied looking at that population. And they put together a 6-week protocol. You basically get 18 minutes worth of stim 5 days a week for 6 weeks. The research on that showed something like a 68% response rate and a 48% remission rate, which is like dramatically better than you can get from any medication.
And
And
in a short period of
that,
time.
yeah, exactly. Right. Now, the thing is, and this is a really important thing to understand. Depression is not a TMS deficiency. Depression is not a DLPFC lesion. Depression is a problem with networks. Okay. Depression is something that involves your whole brain. You can have one area that's critical for that function, but that doesn't mean it's coming from that area. It means that that area is, an apex involved in a lot of pathways. Lots of stuff basically summates in that area, but that doesn't mean that's where the problem is. Now, the thing is, when you start looking at what happens with concussions, if you just look at like classic depression that happens, refractory depression with post-concussion syndrome, which is the majority of people that have been significantly concussed. If you look at that, I mean, you can have that problem and the injured areas of your brain or brainstem or cerebellum or frontal lobe can be just about anywhere. And you can still wind up in a situation where your DLPFC is not firing very well, not because it itself was directly lesioned so much as that everything runs in there, you know? They did this thing called the Connectome Project a few years back, where the imaging technology had reached the point where now we can not only see what different parts of the brain do, but how they all connect. And the DLPFC is like essentially the most connected part of the entire system. Everything runs in there and it affects just about everything. And as a consequence, if you have shearing forces or diffuse axonal injury or damage somewhere, it's almost inevitable that it's going to influence what happens in the DLPFC at some point. Okay. Now, with that system being a critical node in, again, the default mode network, the salience network, there's a few different ways to look at what those systems mean. The way that I usually explain it to patients, even though this isn't like strictly accurate, is just to say that, your default mode network is sort of like resting emotional tone between thoughts. And you want that to be positive, and when it's not working very well, it becomes negative. And your salience network is how you build emotional context around information, and you want to be able to integrate that stuff appropriately. And normal, you're walking down the street and stuff happens, and you're like, wow, stuff happened, and you keep walking. And when those systems don't work very well, you're like walking down the street, wow, stuff happens, and you just immediately default to this negative self-talk. And it's like, and what is it about me that makes all this stuff keep happening? And now I'm going to catastrophize and die alone and unloved or whatever, right? And that's a circumstance where people just can't successfully integrate that kind of information correctly because of those networks not working very well. And that sets people up for chronic depression and chronic anxiety and PTSD and catastrophizing and so on and so forth. All right. So the point I'm trying to make is that you can affect those systems by directly stimulating it, and it'll help in some cases, if that's where the integrated problem is. If it's on the other side of the brain, well, then you need to understand that. And if it's in other areas that are feeding into that, you need to understand that as well. Now, we've been doing TMS as part of our neurorescue program for years, right? We've been looking at doing TMS as an integrated therapy within all of our, I shouldn't say all, but within the majority of the patients that we work with with post-concussion syndrome. And we were, and we probably still will publish on this at some point. We just got way too busy, never quite got around to it. But we tracked our first 300 patients that we did this with, the first 300 week-long intensive therapies that involved us doing TMS. And like I said, traditional TMS, like 68 response rate. Our response rates were like 96%, I think. And our remission
Amazing.
rate was in the high 80s, you know.
Wow.
And that's doing TMS twice a day over 1 week, coupled with the rest of the therapy. And that's the whole point, right? Because it's not just about being able to stimulate that one area. It's about getting your entire brain to light back up and integrate correctly. Okay. And that requires being able to map out everything that's wrong, where everything has the problem, and then coming up with an appropriate protocol to be able to fix whatever it is that you find.